Thank you for having me. I hope you have a great time. I know you had a drinks yesterday, so I'm happy that almost everyone is here today. I just the talk is in English, although if you want, ja mogę mówić po polsku i mogę przedstawić Państwu tę prezentację w języku polskim. Wiem, że mamy tutaj w wielu językach, mamy wielu tłumaczy. Sorry, I'm just joking. I was talking in Polish. But we have a live translation, so I hope they keep up and did translate some of it to you. No, they don't, but they're doing a great job. I have 40 minutes, which is a great achievement for this conference. I know we have Paul Hudson, the huge star. We have a point-free guys, but I have 40 minutes. I don't know, there are signs. Also, I want to do one more remark. Have you seen the Lost in Translation movie by Sofia Coppola? Yeah. It's a great movie. And there's a scene when the director speaks a lot of Japanese words, and the translation is more intensity. Right? It's a very famous scene. And there's quite similar now when the team said, oh, there's a lot of words. The Japanese sounds a bit of a lot of words, and there's just one word in English. I don't know how it works, but it's funny. Okay, my name is Marcin Krzyzanowski. I'm going to talk about the TextKit today. I don't know if you're familiar with the TextKit, but yeah, I will cover the modern approach to TextKit. My name is Marcin Krzyzanowski. You may know me from Twitter. This is my handle on Twitter and my website. I've made some open source projects. The most popular is CryptoSwift, which is the cryptography primitives implemented in Swift. I maintain the online Swift playground. I know you have in your community another Swift playground called Swift Fiddler. Author is in the first row, so we kind of competition, and I really appreciate the work of the Swift Fiddler here. My latest project is ST TextView, and ST TextView is the project that this presentation is based on when I worked on the TextKit internals, specifically TextKit 2. I work at Judah. Judah is a startup that where we build interface builder for Swift UI. I encourage you to check it out. It's markup application with the SDK. It's very approachable way to learn and use Swift UI, especially by the designers. All right, so the year is 2024. And what year is that? Well, I don't think we had, no, yes, we had, yesterday we had a presentation about that. So this is obviously a year of prompt engineering. So AI. The prompt engineering is all about text. And AI is all over the place. But what is AI in the sense that, in the use that we have today? Is basically translating text to something else. Mostly text to text, but also text to image. And OpenAI has this project that generates the video, which is very impressive. But how do we get the string onto the screen is, well, it's a question, and the answer hopefully will come up today. But the TextKit is one of the tools that you can use. How to lay out string, which is also important, especially for the Japanese community, where you have more scripts than any Western language. How to edit string is less of the TextKit problem. It's mostly the editing of the string is still drawing, layout string, and communicating with the system-provided input engine to, so it feels naturally. So we can establish the text is a king, which is quite interesting. We thought that we're gonna draw, that we're gonna speak to the computers. We can speak, but like with the AI, we all back to the text. So this is my invention that the TextKit is a prince. Of course, the TextKit is only available on the Apple platform. This is a framework available on the Apple platform for multiple years. It's built on top of the Cortex. Cortex is low-level framework library, C library, that Apple built to lay out and draw text. And on top of that, there's a TextKit. TextKit happened because Cortex itself is very simple. Well, it's quite simple API, and it has bugs. And TextKit is here to mitigate and fix all the bugs from Cortex. It's higher level API. With the TextKit, you have amazing flexibility to create professional-grade text layout. And with this flexibility comes a lot of complexity. Although the complexity was mostly true with the TextKit 1 that we knew for 20 years, I think 20 years, it initiated in the next step. So predated the macOS on the early versions of the Steve Jobs and team work at Next company. A few years ago, about 5 years ago, Apple started to use TextKit 2. First, they deployed it internally as a private API. And eventually, they announced public API, TextKit 2, that is on the way to replace TextKit 1 API. TextKit 2 is supposed to solve all the problems. It may be. It's still it's young. The API evolves, is implemented in Objective-C. I know this is a try-Swift, but the API is in Objective-C. You can feel that here and there. The Swift API, of course, is available, but there's no such thing like async support. There's support for dispatch queues to do some work in the background. So you can feel the Objective-C still in that framework, although it's a modern framework. Let's do the overview where we can meet the TextKit. So the TextKit is in all the controls provided by the UIKit or AppKit, not WatchOS, not WatchKit, WatchOS, because TextKit is not available on WatchOS. That's the only one. Everywhere else, we have this UI label or NS text fill on macOS, NS text view on macOS, UI text view on iOS. Those are the controls that use the TextKit as a base to display the text, and it's most common interface that you may interact with. The UI label is an interesting one. I think for a long time, it did not use TextKit, but at some point, I don't know, iOS 7 or something new was upgraded to use the TextKit. For that reason, for some time, it could lay out font, like the glyphs, fonts, characters, slightly different than everything else. But it's aligned now. And yeah, everyone is familiar with how it works. When it comes to the text and layout text, we have a canvas. So we draw the text on the canvas. We have some measurements, height and width, padding, and everything. What I wanted to stress out here is that the view and the frame of the text is not the same thing. the text is layout in a frame, in a text container, and eventually, by accident, but most frequently, is also drawn on the view, on the canvas. But those are distinct ideas. When it comes to text, we have some instances of the text elements. So we have a character, like T here. We have something that can be a paragraph, of course, and line. Those terms will be, you will use those terms when work with the text all the time. The thing that just highlight is the frame. It just happened that is the same size of the view, but it doesn't have to. And that's my idea. The text view is used everywhere on operating system, on applications. If we open the keynote, that's most of the elements visible here uses TextKit. So it's really everywhere. It's useful to be proficient in that, or at least know how to use it. Another application is writing the editors. This is my project Swift Studio, when I implement the editor for Swift Studio using the TextKit tool, and this one view is this, it uses TextKit 2 and the project as the text view. Okay, so let's talk about the design of the TextKit. It consists of 3 layers. So it's kind of MVC, but that's not MVC. There's a storage. Storage as a model, source of the data input. It may be a file, it may be a stream, wherever you think, wherever you want. Then there's a layout engine. This is where the majority of the magic happens. Layout is responsible to get the measurements of your text container, frame, and layout text properly. That includes all the scripts, all the fonts, all the direction of the text, so left to right, right to left, vertically. This is responsibility of the layout. And finally, after we have a layout ready, we can display text. This is the third layer of the text. Displaying is just putting or drawing characters. How to translate to the views and to some of the elements. So displaying is just drawing. It's a presentation layer. It can be literally anything. You can draw to the view, but you can stream that over the network. It's kind of abstracted, although the TextKit provides some of the implementation for you that is ready to draw that on the views. What's interesting, I pointed out the pixel alignment. I don't know if you're familiar with the pixel alignment idea on the macOS or iOS. So the pixel alignment is responsible. The result of pixel alignment is whether the text looks sharp or a little bit blurry. When you draw the text between the pixels, it will start to be blurry because the part of the line will be drawn like on 2 pixels. Not a single pixel will be fully bright. Pixel alignment solved that problem, just moving a bit, just slightly, the position so it looks better on the screen. This problem is non-existing in SwiftUI, where the pixel aligning for all the shapes, all the text, all the elements is handled by the framework. if you work outside the Swift UI, it's a very common problem, especially in the core graphic, where you have to, as a programmer, have to care about the pixel alignment. Yeah, so we have display on the canvas, drawing, and so forth. We can draw on multiple primitives that we are familiar with. So this UI view, CA layer, CA metal layer, if you want to utilize the metal performance, and so on and so forth. Then we have a layout. Layout, that's the main layout engine that works in the text container. The text container is the frame of the text. It uses as input attributed text. Attributed text, as you know, as ANS attributed string, or the new version attributed string. It's still used as a rich representation of text. The layout is split in multiple layout fragments. On top of that, there's the viewport, and that's the new concept of TextKit 2. The viewport is like a window that we look through to see the visible portion of text. This is provided for the performance reasons, so the engine do not have to render and lay out the whole text all the time. It just care about this visible part. It have a significant impact on the performance and the memory use. Also, the layout provides a selection engine. There's a selection controller. I will show how to use that. It solves a lot of problems with the selection. Text selection is a very hard problem, especially when the text change from right to left in the middle of the text. It's a very hard problem to solve, and the TextKit 2 has a tool that do it for us. Finally, those are the names of the objects that translate to those ideas. We're going to back to that. Finally, we have a storage, and storage can be anything. Actually, in TextKit 2, the storage is abstracted, and yeah, it can be file, it can be anything. You can implement your own storage provider. Starting from the storage, base model is NS Text Content Manager. That's a protocol that generate multiple text elements. It's all abstract. So the content manager takes, I don't know, from memory, from wherever you want, some part of the text and generate element. This element can be a line, it can be a word. By default, it's a paragraph. And this text element is then transferred to the layout manager. And layout manager take the text into account and produce all the positions for the to display. And that when it's translated, it's called NS Text Layout Fragment. There can be multiple fragments for single text element. It is ready to display. You can massage that. You can change, enhance, whatever you want, but it's ready to, it's positioned already. Then it goes to the viewport layout controller, which is this window, and it's up to you, up to the programmer to put those elements, those fragments, in the visible area. So back to the view, that's how it translates to the object. We have an NS text container. You may be familiar with the NS text container, this frame. It was with us for a long time. That's the same component from TextKit 1. It's a frame. Then we have text element. Here it's a paragraph. And the layout fragment is some piece of the element. Here it's a line. In a code, I will show you how to use the TextKit to code to layout text. So we first create an NSText container, which is a frame. So we say where, in what area we're gonna lay out text. Then there's a default implementation of NSText Content Manager. It's called NSText Content Storage. It uses NSText storage that you know from TextKit 1. You know, this component with the attributed string. Set up the layout manager, saying that instantiate the layout manager, set up the text container, and add layout manager to the content manager. Fill some data, so set attributed string to the content manager. This is what I want to display. This is lorem ipsum, very long text here. And now I ensure layout, which is I force to run the layout machinery on the whole text. The for content manager dot document range it means ensure layout for the whole range of the characters. Once I have that, I can enumerate all the fragments from the layout manager. In each loop, I get the fragment, and I can put it on the screen. Here, each layout fragment has a method draw that is provided automatically, and it draws the content of the fragment in the current graphic context. If you're familiar with overriding a draw in UI view, NS view, or any other component like this, that's the same concept, so you can manually draw something. You don't have to use that. You can implement your own. You can override this draw method, but that's the place to draw the fragment. And as a result, the result is that. And even longer. So what happened here and why it's so long is because I created NSText container with the default values. NSText container with the default values means the width is 100,000 pixels, and the height is also, I think it's 100,000 pixels. So, and I put only 2 lines, so the layout manager used all the available space in the container to do it very wide. Now let's try to keep it narrower. So I specify update the size of the container, and the width is 300, and height is whatever you want, like the very big value. So expected result here is the layout manager will constrain to the given text container width. I also added some boilerplate code here to generate the PDF itself. The generating PDF itself is easy, but the point of that is to demonstrate that I don't have to use the view. I can output to anything. In that case, I output to PDF file. The result is way better, so the layout manager did the work, and layout text vertically, it's a long text, but it fit the constrained content container. How to customize, how to work with this API further. Very typical for the Cocoa solutions, we have a delegates, so nothing functional, Swift, nothing like that. All good delegates. Content manager, has a delegate, and where on each delegate you can return your own implementation of the text element. And this text element is a protocol. So you always get some specific implementation you will return, and it looks like this. In that case, I return custom text paragraph, which is a subclass of NS text paragraph, which may have some additional properties that I need. Right? That's the entry point for that. This is used by the storage and by the layout manager. Next is the layout manager delegate. Same situation, we have a delegate. And the delegate work the same, but the third customization entry point is the text container. It's an good old text container, and it's very powerful, including the exclusion path. The exclusion path is that area that layout engine will exclude from the layout. So you can, like here, draw, have a circle inside, and say, do not touch that area. Then this text container has multiple properties. Not all of them are used with TextKit 2, so it needs some experimentation. Some of them, like you see, there's a fourth line which says layout manager, NS layout manager. Well, this is TextKit 1, so in that setup, we don't use that. It's like an old world, but the NS text container did not change that much. And it's still, that property is still here. Beside the exclusion path, there's break mode, padding. If you want to add some padding, that's the place, not like adding artificial paddings to the fragments. Yeah. So the delegate gets the delegate has the fragments, and I can massage that fragment in a delegate by returning my custom fragments. And here, my custom property is show invisible characters, for example, and it's a custom st text layout fragment. So this is the place where you put your customization. Finally, on a display, you can override the draw method. By default, it draws to the CG context. You don't have to use that. Just use wherever you want. Add a custom drawing here. You can add ornaments wherever you want. And the view layout controller, it asks you to provide some properties, like what is the bound, what is the visible area, and the entry point, those are just checkpoints. Will layout, did layout, use it for your convenience. I mentioned a navigation in the sense of selection and things like that. When it comes to navigation in TextKit 2, everything is abstracted. Like, it's very similar in concept to the Swift string. So the location is, I think I went back. The location is a protocol that only has one required method, compare. And the location, by default, means conceptually, those are characters. But if your implementation works on lines, the location may work on lines. If you may have a very different needs, and you can implement your own location. This location is returned from the storage manager, and only storage manager need to understand your specific implementation. It's on a high level. There's no glyphs. In TextKit 1, we had to work with the glyphs, like low level, no how font works, there's no need anymore. Yeah, so this is the content manager in the two places. There's location, there's offset. From location to location, what is the offset? Very similar API to Swift string when we cannot use just integer to find the offset of the string. We need to have a starting point and offset, and we get an endpoint. The navigation that solves many problems in a selection is NSText Selection Manager, is the selection navigation. NSText Selection Navigation, that's a controller that is available on the Layout Manager. And the use of that in terms of API is quite simple and very powerful. That means you specify the initial location in the sense of the location or the point, like the XY value, says where to move by word, by character, by paragraph. There's a list how far you want to move, whether extend or create a new selection, and you get the range as a result. So you don't have to care about the logic. That's an interesting fact about that. While I was working on the ST-text view, not that long ago, somebody asked why the selection in my component worked differently than in Safari. The thing was, when you hold Shift and select backwards, it worked differently. And I did the research, and turns out that the selection works differently, depends whether you use TextKit 1 or TextKit 2. In TextKit 1, all of that was implemented manually, and I found the code in WebKit, the open source repository. They have all the logic implemented that work with the selection, but in TextKit 2, we just used that method, and it worked consistently everywhere. As a fact, text edit application, the system macOS application, works just like my components. It uses TextKit 2, but Safari worked differently. Also, NSText view, which is the macOS UI text view, selection worked differently, depends whether you use it in the mode of TextKit 2 or TextKit 1. And I guess the new approach is the good one. If not, it will automatically change for me with the new update. I don't need to care about that, but that's an interesting fact. The selection in like how it looks, how it works. It may work like this. This is my component. You can see on the left. On the right, the NSText selection is just this object returned by the previous call. It gives the range, affinity. Affinity is which point your selection goes towards, and granularity. Here I ask for the character. It can be word. It's very simple API to use. It saved me a lot of work, I must say. Back to the list of the components. So everything I said is now gradually implemented into the system components, and all of that components use TextKit 2. But UI text view, NSText view, how it is implemented today, it's been 3 years as an open, as a public API. Works in both modes at the same time. It can work on both modes at the same time. I understand why Apple chose that word. It's like a gradually introduced a new solution. it has it comes with the problems. As the year by year pass, some of the features that already works in a UI text view was not available with the new TextKit 2. At that point, the text view can switch to the old mode. Like it switched from TextKit 2 to TextKit 1. It has a performance impact because it has to translate all the model, all the data or the layout to the old one, and then switch back to the TextKit 2. It can be problematic, but for some of the feature of text view, it still happens. That means not everything, not all the methods known from the UI text view will work with the TextKit 2. Like there's a method to draw the insertion point, and there's more that just are no operation these days. It's problematic, I would say, but that's the word we need. My approach was to completely disable TextKit 1 and try to do everything with TextKit 2. That led to many workarounds because not everything is ready, production ready, unfortunately. In an app kit, the typical use of the text view with the TextKit 2 is like this. That means it defaults to TextKit 2 setup. We no longer default to TextKit 1. We default to TextKit 2. When I create UI text view, it's ready to work with in the TextKit 2 setup. And this is the most typical use when I set up the text, add exclusion path in the middle, in the circle, and said, OK, layout text excluding the part, and the result is, as you can see. To customize, just set a delegate, and and I can do all the customization. The application of the TextKit is very wide, very broad. Those are text editors. The most known editor that uses TextKit 2 is probably TextEdit, the System 1 editor, and mine, of course. But it uses all over the place. I don't think the iBooks application uses that. I think they still use the core data. Maybe at some point they will. The programming editors also uses TextKit, except Xcode. Xcode uses the custom implementation of the text editor. As a result, some of the bugs, if you compare, TextKit with your work, may work differently. It doesn't mean that the Xcode is on the right side. Usually, Xcode is doing something wrong. But there was a reason to do it that way, because the TextKit 1 performance is not good enough for long text, and Apple decided to implement their own editor based on core text, which is the lower level API, but it gained the performance needed for the programming editors. The list of bugs for the TextKit 2 that I reported over the time is quite extensive. It's not everything. I just put what I addressed and work around in my implementation. Also, there are some bugs that are only applied to NS text view, and those were the reason why I dropped NS text view and started to implement my own text view component. And I thought that it was going to take a week. It's, I don't know, a few months already, or maybe a year, and still finding something new to do. But it's very enjoyable. I encourage you to implement your own editor. A lot of fun. You can spend a lot of evenings with that. To wrap up, the TextKit 2 is default now. All the operating system except watchOS, where the TextKit is available, default to TextKit 2. The design consists of 3 layers: storage, layout, and it should be display. You don't need to view. You can layout, draw the text on any surface you want. The adventure with the TextKit is through the default components: UI text view, NS text view on macOS. Customization comes with a delegates pattern or some subclassing. And NS Text Content Manager is very powerful. You can implement that and customize it for your needs. It's very powerful. On that note, although the design of TextKit 2 is very good, I really agree what they did. The implementation part, how it is implemented, have some blind spots, maybe. That means there's a connection that shouldn't be between NSText layout and specifically NSText view or UI text view class. It shouldn't happen because I don't use UI text view or NSText view, so I cannot take advantage of some of the performance that Apple used privately when communicating, between the TextKit and the specific implementation provided by the Apple. That's a private API. I think it shouldn't be a thing, but they decided to, maybe they had a reason. But it kind of breaks the whole nice design. There's not much documentation when it comes to TextKit. We have 2 sessions, actually 1 session when it was introduced in WW21. Meet TextKit 2, 20 minutes of WW format video. It comes with a sample project. You can download the sample project. It's not great, unfortunately. It's like not the best implementation of TextKit 2, unfortunately. You may find some issues even when you play, like the selection is broken there. Then the following year, there was what's new in TextKit and TextKit View. Some more information, then improve the TextKit. So there's another 20 minutes, and that's all. There's not really more implementation when it comes to how to use the TextKit 2. But if you're interested how to use it, yeah, I encourage you to check out the text view, my project, where I use it all over the place. I have a supporting project, TextKit Plus, which are the extensions to TextKit 2 classes that I use over the place and may be useful for you. Maybe at some point we're gonna get some proper documentation. The documentation also has flaws. Sometimes it's missing, but even when it is provided, it's very short and has bugs for many reasons. Oh no, it's only 3 years. Maybe in 20 years, it's gonna be great. Who knows? When you're gonna search for the TextKit documentation, there's great documentation for TextKit 1. It's 20 years or maybe 15 years old. You know, all this archived documentation you can use to some extent when it comes to how the NSText container works, but everything else is different. So, but it's a good documentation to get to know or learn about concepts about text layout at all. That's all, folks. Thank you very much for your time.